record.
Record. Hmm. Good morning. The project which we have been working on is analysis of mobile app usage. We are in the weekly development process report status. The latest track is the project is on track, and the latest reporting is 14th of November. The next slide, please. These are the table of content which we are using throughout the PPT. Next slide. About our project, this is a project in which we are analyzing the mobile app usage, the behavior, and the results have been taken out of a survey. Unique trends preferences have been identified. The main objective is to improve the overall user experience and to enhance the design and functionality. The deliverables are transferring knowledge, all research analysis, visualization analysis, testing, coding, formulas, and algorithms, and practical recommendations of the app development and insights to the marketing. Can I get the next slide, please? So, in our team, my name is Mandeep. I am the team lead. Alongside, I have Obianju. She's working as a data analyst, and Akashdeep and Rahul Maneria are both developers of the team. The next slide. Okay, the communication update. The frequent communications have been held through the WhatsApp group, which we have on WhatsApp and basically on phone calls. We also have Zoom and Google Meet for the communications. Next slide. The planning phase is the one which we are currently working on. Can I get the next slide? Yeah, in the planning phase, the dataset has basically a survey which has been carried out of 10,000 people from more than 15 countries analyzing their mobile app usage. The countries include US, China, Japan, France, Brazil, Russia, India, and 15 countries. And the development and approval of the project documents have been done through project charter and MRP proposal. The next slide. Okay. The planning phase continues. So in the technical cleaning has been done, removing all irrelevant columns, ensuring there is no null values, absence of duplicates, coding and categorizing of some columns have been done, and the five personality trails we have in we have in the data set. Let's like open, conscious, and can I just show the Jupyter notebook? Yeah, so here we transfer the whole data into MongoDB. That's the database we are using, and we are trying to fetch the whole data, whole data from the MongoDB database. And here is the code in which we have the whole data set. The whole program has been working through the MongoDB. Yeah,
Yep.
can you go back to the PPT? Yeah. Now, can I have Akashdeep continuing from this one?
Yeah, thank you, Mandeep. So, in the design phase, we aim to gather data that captures a broad range of behaviors and motivation behind the app usage. Can you go to the next slide? So, yeah, so this distribution is that which customer uses which type of mobile, and here we see that the Android users are on the top, and after that, the Apple with regards to our data set. And this is also somewhere true in the real world scenario. And next slide, please. Here we looked at the individual app related behaviors. When people search for an app, they often explore options randomly until they find something suitable. Sorry. However, app reviews significantly influence their decision making process, but purpose also plays a big role. Like people tend to download apps that serve as a specific function, like utility apps. Examples such as calculator being popular choices in utility apps. So next slide, please. Moving to the demographic data, most survey participants were full-time employees, undergraduate, and married individual, mostly aged between 20 and 40. Here we see the different types of charts that shows the insight at how employment status, education, gender, etc. tells more about our individual variables. Gender gender representation was nearly balanced here, and females are slightly ahead at 51.6%. And next slide, please. So this slide represents the big five personality distribution within our data set. This chart here shows the frequency of each combination of big five personality traits, displaying various combination of personality traits. Unreported stands out as the most. common category indicated many participants didn't specify their personality traits, but among the reported traits, combinations such as agreeableness, openness, and extroversions have higher counts. Next slide, please. For bivariate analysis, can we jump to the Jupyter file? So yeah, below, more. Yeah, here. So yeah. So App Store preference by gender. Can you show the charts, please? Yeah, now on to bivariant analysis. So here we discover distinct App Store preferences by gender. Males are more likely to prefer Nokia and Windows platforms, while females have been towards Apple and Android. For occupation and app type bar chart, we found that around 70% of employed users tend to download utility apps with fewer downloading entertainment apps. And reason for downloaded apps by gender, the third chart. So looking at reasons for downloading apps by gender, we observed that females are more likely to download apps for entertainment. This data reflects different motivation across gender and provides insight for app creators to tailor their app features accordingly. And the fourth chart, deleting apps by marital status, we saw that married users tend to delete apps more frequently than singles. However, single users are more likely to delete apps that they find difficult to use, indicated a higher expectation for user-friendly design. And can we go to the next slide, please? Oh, yeah, here. So here, yeah, personality traits. So finally, analyzing personality traits in relation to app deletion, we found that individuals with single personality traits delete apps for a variety of reasons more often than those with the multiple traits. This could suggest that certain personality characteristics led to lower app retention. In conclusion, with all this EDA analysis, we can say that this analysis provides valuable insights into how demographics, app purpose, and user trait influence app users' behavior. These findings can be useful for app developers looking for better understand their target audience. So here I can ask my colleague Rahul Maneria to continue on the next slides.
Thank you so much, Akash. So, as we already know that we have done univariate, multivariate, bivariate, and right now we are on multivariate. So, we thought that why not to take two columns and find insights in between them. For example, considering app by country of residence. For example, which kind of uh, of people of which country consider app for what reason, right? So here we can see that, for example, Canada, China, and this consider apps mostly on the reviews, right? Because these are showing the most value, highest value here, so they consider app according to reviews. Then reason for delete. So what is the reason of delete according to country? Is there a difference that Canadians delete the app because of another reason as compared to Chinese people, or maybe Indian, right? So this is very insightful here. Here we can see that most of the people deleted them because they find alternative instead of just deleting for other or utility or another usability or another reason. So most of them are downloading just for alternative. But here, Republic of South Korea, we can see that they are downloading for they are deleting for an unknown reason, right? Because that is the most count there. And then talking about type downloaded by country of residence. So which type of app are downloaded by which kind of people? So most, as we have already discussed that in univariate and bivariate analysis, that most of the apps are downloaded in utility department. That is either calculator, or it can be measurement apps, or it can be PDF scanner, or those kind of stuff. And the reason for download by country of residence, again, most of the people download it for a purpose, while other followed by entertainment. Here we can see that most of the values lies between purpose and entertainment. Let's move to the next slide. We have also plotted a heat map there to show it. So for so far we were just considering the numbers, that okay, this is the count. This means that okay, Canadians are most who are downloading the apps, Chinese are most who are downloading the apps. But the final conclusion is there might there is a possibility that Canadians have indulged more into this survey as compared to other countries, right? So we cannot conclude it just by number. So we thought that, okay, why not to find a proportion, that is percentage. Okay, whatever number of Canadians were there, out of them, how many percent of Canadians downloaded the app for this reason? How many percent of Canadians have deleted app for this reason? For example, if there are only 10 Indians, and out of them, 8 are downloading app for a purpose, that means that 80% Indians try to download it for a purpose. Although it's just a sample data, not a population data, but we can conclude it in a percentage proportion, right? So these are some of the graphs which are just for percentage proportion. And although, however, the limitation of this analysis is equally, that is what I already told, that unequal numbers were there. That's why we have plotted a percentage, and insights were similar only. And then let's jump back into the code, and let's continue from code there. Okay, so this is the percentage proportion which we can see. So we have found a different insight as compared to the number here. And then let's go to the next slide, next graph, that is Sunburst. So this is nothing but this analysis shows the distribution of type downloaded app by the country of residence and big five personality traits. That is, which country is having which kind of personality trait. Let's move next. Go back to the slide. It's very easy to explain there. So to conclude, we have also done hypothesis testing, that is there a significant difference between the between the age of the people and downloading type, or is there a significant difference between male, female, and their type downloaded? So we found out using the ANOVA and Kruskal-Walsh test that yes, there is a significant difference. That is, male prefer different kind of app, female prefer different kind of app. Then go next slide. Go next. Development phase. In development phase, as we know that we try to find which features are more important for our conclusion. That is to reason for delete, reason for downloading. So we have considered each and every column as a target column, and then found out that which columns are most contributing to predict that column. So that is what we can see in this graph. Next slide, please. So still our target columns were not specified, but we have taken each and every target column, and that is what we are plotting, that okay, these features are most contributing to predict that target. Next slide. And then we have created a cluster on top of it. So this is the clusters which we can see that okay, we had taken two columns and created a cluster, and this is the cluster which you can see. Go to the next slide. This is a clustering continued. We have tried all different permutation and combination of two columns and plotted different kind of clusters on top of it. And then finally, these clusters were not that much insightful. So we have created a PCA, that is, we have fed the whole data set and told the PCA that okay, this is the data set. Just create clusters according to you. So in next slide, please. So this is the cluster which we got, and then we have next slide. And then in PCA loadings, we have so that okay, which columns are most contributing to create which cluster in that PCA. So this is what we found, that okay, big five is contributing towards PC3, PC5, and another column is contributing towards PC1. This is what we found. And from here, I think I can hand it over to Uju at what predictive modeling we have tried.
Thank you, Rahul. So for the predictive modeling, we applied 3 methods because we are trying to know the best fit. First, what we are aiming to achieve at the end of the predictive modeling is to know our preferred target column based on the level of accuracy in both training and testing, and also for us to know the preferred model for the prediction. So first, for the random forest, we were able to employ it, and it worked effectively with the use of the smooth. Let me go to the code. I think the code will explain it better. With the use of the smooth model, it helps in balancing the nature of our categorical data and made it to balance all the irregular columns that are fewer in numbers. So with that, we are able to achieve high accuracy actually, but in the testing, it's quite a bit lower. So across the entire three proposed target column that we have, which is type downloaded, reason for delete, and then reason for the download. So, but in this, for the random forest, we are able to discover that type downloaded performed optimally in the testing, not just the accuracy. The next one we employed was the decision tree. So in the decision tree, it actually gave a very, very low accuracy, and the testing was a bit higher than the prediction, but is not actually very adequate to what we hope for. The reason for download was giving these figures, then the reason for delete was giving these figures, and then the type downloaded this. The next one we employed was the naive Bayes. So this also gave a prediction, but not really as the random classifier. So, and at last, from the presentation, we were able to conclude that despite all the three categories of the predictive tried, we were able to conclude that the random forest is more reliable, because not that the accuracy is higher, the testing is also quite optimal, above 84%. And we have concluded that of all the proposed target columns, our best fitted target column is the type downloaded, which suits the objective of our analysis, because with the type downloaded, we'll be able to dictate which sex we are able to, the type they are able to download. We're able to dictate other, both the demographic data, both the big five personality, what actually informed their downloading of the app. So the best fitted target for our analysis is the type downloaded column, and our best model is the random forest classifier. Sorry, there is no Power BI.
It's okay. I'll share my screen. I think there is a glitch in your system. I'll just share my screen just quickly. Quickly share my screen. So this is the Power BI dashboard. I think you can see my screen. You just stop sharing your screen. This is the Power BI dashboard prototype which we built on top of it. So we will be trying to improve it further. We will be trying to conclude it. We will be trying to make it a perfect dashboard. This is just a prototype for now and work in progress, as you can see that. And talking about the project cost, so planning, design, and development, these were our project costs. Budget cost was more as compared to actual cost. Actual cost was pretty much less. We have already taken budget cost more, and that okay, take this cost, but we are trying to decline the actual cost here. And then challenges encounter, I think Uju can explain it better.
The major challenge that we had was just our data set being categorical data. So we had back and forth trying to employ the clustering and the predictive modeling. But at last, we were able to employ many methods that helped us, such as the label encoder, hierarchical encoding, frequency encoding, but that helped us to manage the diversity of our data sets and the categorical of our data set, converting them to numerical, and helped us to get a close to optimal predictive modeling. Thank you.
That's it. Thank you, Uju. Thank you, Akash. Thank you, Mandeep.